Hello, guys. Welcome to the class. So before we take a look at the assignment one, why don't we take a few minutes to take a quick review on what we learned in the last class. So the first, we learned about Heron's formula. So for Heron's formula, we can actually calculate the area of any triangles if we know the three sides of that triangles. So what we do here is we calculate the perimeter and we divide by 2 and we mark that one as S. Then we plug in the formulas S times S minus A, S minus B, S minus C to calculate the final result for this one. So that is actually the first question. So now, okay, we have a triangle. We don't know the base and the height, but we do know the three sides length. So we can actually using Heron's formula for this one. So what we do here is why don't we call this one is A equal to 8, B equal to 15, C equal to 17. So first we need to calculate the perimeter of this triangle is A plus B plus C. This one is 23 plus 17 equal to 40. Okay, the perimeter is 40. So the S will be equal to the perimeter over 2 will be equal to 40 over 2 equal to 20. And then we can plug into the Heron's formula. So the Heron's formula is S times S minus A, S minus B, S minus C. Okay, and S we just calculate is 40. And the difference between S and A is 32. And S and B is 25. And S and C, the difference is 23. So for this one, or the important thing is you can use the formula. It's not how we calculate the final result. So if you actually get the numbers here, you can directly like plug into the formulas we have and using the calculator to calculate the final result for this one. So for this one, the answer will be B for this one. So you can directly just using calculators to calculate the final result for this one. And we choose B for the right choice. Okay. The important thing is about the formula is not how we calculate the square root of this number. Okay. Any question regarding the first one? Okay. And in last class, the second thing we talked about is similar triangles. So what is a similar triangles? So we said two triangles are similar if their corresponding angles are equal and their corresponding sides are proportional. Or in simple words, we can say, okay, we have two triangles here. We have a triangle ABC and we have triangle DEF. Look at the graph here. Those two triangles, they look the same. The only difference is the size, right? Where based on this graph, we can say, okay, the triangle ABC is basically 2 times bigger than DEF. Okay? And how do we represent this similar thing is we can say, okay, angle A is equal to angle D. Angle B is equal to angle E here. And angle C is equal to angle F. Okay, the three corresponding angles are equal, right? Two triangles are similar, the shape is the same. So the three corresponding angles, they're equal. And the sides are proportional. So we assume, okay, triangle ABC is 2 times bigger than triangle DEF. So this one we can mark as, okay, AB, the side length, the corresponding side length ratios will be equal to, hold on, DF is equal to 2 to 1, or you can just mark 2 here. So the side length, the ratio will be 2. So we actually say, okay, the first triangle is 2 times bigger That's the second one. Okay. That's the definition of similar. Okay. Now, how do we actually prove two triangles are similar? Is we have three ways to prove two triangles are similar. Okay. And why do we need to prove two triangles are similar? It's because okay, if okay, the angles of A is given, and the angle B, the degree is given, and we want to calculate the angle F here. So if we know those two triangles are similar, we can directly, okay, because those two triangles are similar, we can get, okay, the angle D is actually equal to angle A. Angle E will be equal to angle B. Now we actually put three angles in one triangle, and we can using 180 degrees minus angle D minus angle E solve the angle F. So we can, based on the given information, we can actually solve questions. And that's why we need to prove two triangles are similar. Okay, the three ways we talk about, the first thing is based on definition, we need to prove the three corresponding angles are the same. So look at here. To prove the first triangle ABC is similar to the second one, we're actually using, okay, angle A equal to angle, if we have those given informations, angle B, hold on, we can actually using angle B equal to angle E, angle C equal to angle F. Now, two corresponding angles are equal. The third one will definitely be equal to. And because for any triangles, the interior, the sum of all the interior angles will be 180 degrees. If you already proved two of the angles are equal, the third one will definitely be equal to. So you actually prove those two triangles are similar. We actually call this one AA, the angle, or you can simply ask AA because two angles will be enough. And we can also using the second one is actually right here. You prove the three corresponding sides are proportional. Okay, and you actually get, okay, based on the three sides are proportional. The ratios is always equal to the same number. So we prove those two triangles are similar. Once you prove those two triangles are similar, you actually can use, okay, angle A will be equal to angle D, angle B is equal to angle E, angle C equal to angle F to solve questions. But before that, you have to prove these two triangles are actually similar. That's the second way to prove the similar. Okay. The third one is right here. The sides, two corresponding sides are proportional. If you take a look at this graph, if we have AB, look at here, AC over DF is equal to AB over DE. Two corresponding sides are proportional. And the included angles is also the same. And that's why we call this one side angle side um, similarity. So we're using SAS. We actually prove those two triangles are similar. And if you prove those two triangles are similar, we can say, okay, we already know angle A is equal to angle D. We can also say, okay, angle B will be equal to angle E. Angle C will be equal to angle F. And we also know the third sides will still be proportional. So AC over DF is equal to AB over DE, will be also equal to BC over EF. All the three sides are proportional. And that's because we already proved those two triangles are similar. Okay. And let's go back to our questions. Look at the first one. Okay. In triangle ABC and DEF, the angle B is equal to angle D is equal to 75 degrees. And BA over DE will be equal to BC over DF. Okay, BA over DE. is equal to BC over DF. Now, based on the given informations, okay, this is actually SAS. The two sides are proportional, and the included angles, angle B and angle D, are also equal. So based on SAS, we actually prove the triangle ABC will be similar to triangle EDF, right? Okay, and since you already proved those two triangles are similar, so we can say, okay, because those two triangles are similar, the corresponding angles will be equal. So, okay, now we want to find the angle F. We want to find this one. And we already know angle D is 75 degrees. And angle B is 75 degrees. And angle A is 45 degrees. Okay, now we already proved those two triangles are similar, right? So we can say, okay, angle A will be equal to angle E based on similarity. Okay, so will be equal to 45 degrees. Now take a look at this DF triangle. Okay, two angles are given, 75 degrees and 45 degrees. The angle F will be equal to 180 degrees minus 75 degrees minus 45 degrees, equal to 180 minus 120, equal to 60 degrees for the second one. Okay. Any questions? Okay. The third one, if DEF, the triangle DEF, is similar, okay, the similarity is already given as similar to triangle RQP here, and and DE is 5, RQ is 10, and DF is 12. Okay, we need to calculate RP here. Okay, since we already know two triangles are similar, so we can directly say, okay, because those two triangles are similar, then their three corresponding sides will be proportional. So we have DE over QR will be equal to RQ. D over RQ will be equal to EF over QP will be equal to DF over RP. Okay, now we can just using this too, right? So DE is 5, and we also know uh, the RP is what we need to calculate, and RQ is 10, and DF is 12. Okay, now we actually have the formula. 5 over 10 is equal to 12 over RP, right? Just take a look at the left fraction. The denominator is 2 times bigger than their numerator, right? So we can say, okay, RP will be equal to 2 times 12 will be equal to 24. Or you can also using, okay, this is an equation where we have fraction on the left side. We also have fraction on the right side. So we can directly do the cross product. So 12 times 10 is equal to 5 times RP. You can also solve RP is equal to 120 over 5 equal to 24 for this one. Okay, that's the third one. Number 4. Okay, in this figure, AD over BD is equal to AE over EC. And the ABC, the angle ABC is 70 degrees. And AED is 65 degrees. Okay, now take a look at this one. AD over BD is equal to AE over EC. Okay, if you take a look at the four sides on the angles on the graph in the graph, you may say, okay, the BD and EC It's not even in any triangles, right? But if you just take a reciprocal on both sides, if it's using BD over AD, and it will be equal to EC over AE, right? I just take the reciprocal for both left part and right part. Okay. And what we do here is, okay, we can both plus 1 on both sides, right? BD over AD plus 1 will be equal to EC over AE plus 1. Because this is an equation, right? So if you plus or you minus the same thing on both sides of equations, the equation will still satisfy, right? Okay, now this one will be equal to BD plus AD over AD will be equal to EC plus AE over AE. What is BD plus AD? This is actually AB, right? BD plus AD is actually AB. And EC plus AE is actually AC. Okay, now what we're doing here is we have two corresponding sides and it's already proportional. It's actually triangle ABC and triangle ADE here. The big one, the largest triangles in the graph, and the top small triangles. Okay, those two, we already proved their two corresponding sides are proportional. And they also share the common angle A, right? So the included angles are also equal. So we prove those two triangles are similar. And once you prove those triangles are similar, what we have here is the angle C will be equal to angle AED here. The corresponding angles will be the same, right? Will be equal to 65 degrees. Now, look at here. In order to calculate the BAC, we already know two angles, right? Angle C is 65 degrees, angle B is 70 degrees. So angle A will be equal, or angle BAC will be equal to 180 degrees minus 70 minus 65 is equal to 110 minus 65 equal to 45 degrees for this one. This is number 4. Okay. Number 5. For number 5, if you take a look at this triangle, let's start with vertex K here. The KNP and triangle KML. If you take a look at these two triangles, their two corresponding angles are equal. And it's actually angle KNP is equal to angle KML equal to 50 degrees. It's already marked on the graph. They also share the common angle K, right? Okay. Based on AA, right? Based on AA, we actually prove those triangles are similar. Once you prove those triangles are similar, the side ratios, the corresponding side ratios will be the same. Okay, so the Kn over Km will be equal to Np over Ml equal to Kp over Kl. Okay, so the next step is we can just plug in the letters. So Kn is actually C. Km is B plus C, right? Because Km is actually Mn plus Nk. So it's B plus C. And the next one, the ML, this one is A, and NP is X, is what we want to calculate this one. So the final equations will be c over b plus c equal to x over a. So x will be equal to a times c over b plus c. And that's the answer for number 5. Okay. Any questions on assignment 1? Okay. If there's no questions, we could continue our class. Okay. In today's class, we will basically talk about two theorems. And the first one is we call this one the basic proportional theorem. Okay. What is this one? And take a look at this graph. So the theorem states if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Okay, take a look at this graph. Okay, we have the large triangle ABC, the big one, ABC, the green triangles. Okay, if we draw a line DE, okay, it intersects with the two sides of triangle ABC, right? And this one, DE, is also parallel to BC. And in this way, we actually separate A, AB into two parts. Okay, we separate the AB into AD and BD, right? By the cross point D here. And we also separate the AC into AE and EC. Okay. Now the theorem is basically mentions, so if you do things like this, we directly get, okay, the ratios will be the same. So AD over DB will be equal to AE over EC. So for the left part, if you separate the left part as 2 to 1, then on the right part, you will also separate EC into 2 to 1. The ratios will be the same. Okay, that's the theorem mentions. Okay, and why is that? It's still based on the similarity of similar triangles. So because, look at here, because DE is parallel to BC, right? So if DE is parallel to BC, what do we have here is the angle ADE, this angle, will be equal to angle B. Because the DE is parallel to BC, and then you have a line with two cross points with DE and BC. The angles will be the same. And we also have the other two. Next one, the angle AED is equal to angle C. And they also share the common angle A, right? So all the three angles are the same. What do we have here is, okay, the triangle ABC will be similar to triangle ADE here. The large triangles, the big one, will be similar to the top triangle ADE here, similar to the small one. Okay, what do we have if we already got, okay, those two triangles are similar, then we have the corresponding sides are proportional. Okay, we have AB over AD is equal to AC over AE here. Okay, what is AB? We already said, okay, AB is actually, we separate into two parts. We separate in AB into AD and BD. So why don't we using AD plus BD to represent AB? This is over AD. And for AC, look at here. For AC, we separate into AE and EC. We separate into those two parts. So let's rewrite AC as AE plus EC over AE. And look at these equations. So on the left part, the green one will be equal to 1 plus BD over AD. On the right, we have 1 plus EC over AE. And the 1 and the 1 will be canceled. So what do we have here is BD over AD. BD over AD is equal to CE over AE. Or you take the reciprocal, still works. So basically means, okay, if the left part, you separate the ratios as 2 to 1, and for the right side EC, you will also separate as 2 to 1. Okay, this will help you solve questions quickly. So for example, let me just give you an example for this one. Take a look at this one. Okay, now look at the graph. We have DE parallel to BC. Okay, based on the proportional theorem, we don't need actually to prove the similarity. We can directly say, okay, because ABC is a triangles and DE is parallel to BC. What we have here is the left ratio is equal to the right ratios, right? So we have AD over BD is equal to AE over EC. And EC is what we need to calculate. AD is equal to 2.5. I basically get from the graph. BD is 5. AE is 2. So the final equations we have is 2.5 over 5 is equal to 2 over EC. Okay, we do the cross product. So 2.5 EC is equal to 5 times 2 equal to 10. So 2.5 EC is equal to 10. So EC is basically equal to 4. Solve the questions. Okay, we don't need to prove the similarity of this the big triangle and the small triangles. We can directly using the ratios will be the same. Okay, any question with this one? Okay, why don't we do a small practice? Take a look at this one. I will. Okay, I'll just issue the pop survey here. When you finish, you can just fill it on the blank. Okay, take a look at this one. because the EF is parallel to EC, right? It's already given here. So what do we have here? The conclusion is the two sides, AB and BC, will be divided in the same ratios. Look at here. The total length for BC is 10, right? So we will have the BE is actually, hold on, it's 10 minus 2 is 8. So I will say this, the BE over EC is equal to BF over EF. And BE over EC is actually 8 to 2 or 4 to 1. So, okay, now BE over EC is 4 to 1. That means we actually separate the BC into, you can think as 1 over 5 and 4 over 5 compared to the original length, right? Or the ratios is 4 to 1, it's basically 80% to 20%, or 0.8 to 0.2, or 4 to 1, like this. So I will say this, because EC is 1 over 5 compared to the original length. So for AF, it's still 1 over 5 times 13 is equal to 13 over 5 is equal to 2.6. Solve the questions. Okay, any question with this one? Okay, so the thing here is we don't need to actually prove something. We can directly say, okay, the two sides, because you have a parallel line, which is parallel to the base. So the two other sides will be divided into the same ratio. Okay, that's how we solve the questions. Um, let's take a look at another one. Look at here, this one. We have DE over, it's parallel to BC. AD is equal to X over 1. Okay, for this one will be a little bit hard. For this one is because, but to form the equation is not hard. So because DE is parallel to BC, right? So the two other sides will be divided into same ratio. Okay, the ratio is actually the upper one over the bottom. So x plus 2 over x plus 3 is also equal to the upper x minus 1 over x minus 2. Right? That's the formula we have. Okay, now the question is how do we solve this? Is we can also do the cross product. So, and the left will be x plus 2, x minus 2. The right is x minus 1 times x plus 3. Okay, so for this one, it's actually x squared minus 4. And for the right side, is x squared. You're using the first term times x plus the x term times 3. And then you're using the second term times x and using the second term times 3. So it's actually equal to x squared plus 3x minus x minus 3. It's equal to x squared plus 2x minus 3. Okay. And for this one, the x squared will be canceled. You have on the left side of the equation, you have x squared. On the right side of the equation, you also have x squared. Will be canceled. And you can add 3 on both sides of the equations. So we have minus 4 plus 3 equal to 2x minus 3 plus 3. So minus 1 is equal to 2x. X will be equal to negative 1 over 2 for this one. Right? And you can actually plug in the numbers to prove this is okay. So if you actually plug in the x values, so x plus 2 will becomes, just treat this one as negative 0.5. And the top will becomes 1.5. This one will becomes to 2.5. And on the left, this one will becomes negative 1.5. And this one is become negative 2.5. Look at the ratios. Will be the same, right? It's always be 1.5 to 2.5, right? You actually solve the questions. Okay. Um, but this is just to solve the x values. It doesn't make sense in reality because side length cannot be negative. Just for this questions, you solve the x values. Okay, let's take a look at another one. Look at here. We have a trapezoid ABCD here, and AB is parallel to DC, and the P and Q are the points of AD and BC are on the side AD and BC. Okay, and we also have PQ is parallel to DC, and let's mark the length on the graph. PD is 18. BQ is 35. And QC is 15. We need to calculate AD. But to try to calculate AD, we need to calculate AP first, right? So we can actually calculate because AD is actually equal to AB plus PD. Okay, this we already given. It's already given here is 18. So just try to answer this one. Oh, this one we have to calculate AD, the total length on the left part, not just AP. right? After you calculate the length of AP, you have to plus 18. So you have the total length for AD. Okay. Based on what we just learned, okay, if it should be separate the left side and the right side, it should be divided into the same ratios. Or it seems like we should have AP over DP will be equal to BQ over QC. So, right, the left part, the ratios will be equal to the right ratios. You divide it into two parts and you do the ratios. So what you have here is AP over 18. It's equal to 35 over 15. So AP is equal to 35 over 15 times 18. Simplify this. We can cancel by 5. So this is 7. And 1 over 3 times 18 will be 6. So we got 42. So if AP is 42, then we say, okay, AD is equal to AP plus PD equal to 42 plus 18 equal to 60. So the answer for here for this question is actually is 60 is correct. But the question might be, okay, you just said when you can do this in triangles, but this one ABCD is not a triangles. Okay, this is a trapezoid. It's a quadrilateral. It's not triangle. How can you still use this one? Okay, if okay we connect the BD point, just using a straight line, we connect BD point, and we mark the BD, the cross point between BD and PQ. The cross point, let's mark here with letter let's see, the letter should be A, B, C, D. Let's mark cross point BE here. Okay. Now, if you take, okay, treat the left as a triangles, right? We actually form a triangle ABD and a triangle BDC here. Okay. Once we connect the vertex B and the vertex D, we separate this trapezoid into two triangles. Now you have two triangles right now, right? We can say, okay, because this is a triangle, then the two other side, the ratios should be divided into the same ratio. So we have for ABD, okay, we have DE over BE should be equal to DP over AP. All right, just take a look at the left triangles. Okay, DE over BE is equal to PD over PA, right? You have a triangle and you have a line parallel to the bottom. The other two sides will be divided into the same ratio. Okay, now if you take a look at BDC here, the right triangles, the right the right triangles. Okay, you still have a line parallel to the bottom. So the other two sides will still be divided into the same ratios, right? We have DE over BE is also equal to CQ over BQ. Okay, now look at here. This is DE over BE. This is also DE over BE. So what we have right now is PD over AP is actually the same as CQ over BQ, right? Look at here. Look at what we use to solve the question. It's basically the reciprocal for this one. DP over AP is equal to CQ over BQ. You just take reciprocal on both sides. It also works. So AD, AP over DP is equal to BQ over QC, right? So the left side and the right side are also divided into the same ratios, right? Even though the ABCD is not triangles, you can actually separate into two triangles to prove this one. Okay, any questions? Okay, this is what we call the basic proportional theorem. And okay, now we can also conversely, we can do the conversely. We can do converse of basic proportionality theorem, which means we just do the opposite. Okay, now in the beginning, we actually have, okay, if you have line parallel to the base, then the other two sides will be divided into the same ratio. And this one just do the opposite. If you have, if the two sides are divided into the same ratio, then the line is actually parallel to the base, which means look at here, look at this graph. If the given information is AD over BD is equal to AE over EC. Okay, the left side and the right side divided in the same ratio, then the line DE will be parallel to BC. We can directly use this one. It's actually, you can using this to prove this, and you can also do conversely. Okay. And why do we need to learn this? I will just give you examples. Look at this one. Look at this one. Um, this you can actually treat this one as 2D. You can say, okay, all the points are on the same plate, right? On the same board. Okay, it should be 2D. Or if you learn some sketching or some drawing stuff, this one is actually, it looks like a 3D, right? It doesn't matter, it still works. So now the two things we have right now is DE is parallel to AQ. And we also have DF is parallel to AR. Okay, now we want to prove the EF is parallel to QR. Okay, if you have the red and the blue one is already parallel, we should also prove, okay, the purple one, the purple two lines are still parallel. Okay, now look at here. DE based on DE parallel to AQ. What do we have? Is, okay, AE. I'm sorry, not AE. The P over EQ. It should be equal to PD over 80, right? Because you have a line parallel to the base, then the two other sides will be divided into the same ratio. Same ratio. Okay. And what about if we have DF is parallel to AR? Look at here. Now on the right part, we have, okay, one line is parallel to the base. So the two other sides will be still divided into the same ratio. So what we have right now is PF over ER, I'm sorry, FR will be equal to PD over 80, right? Okay, look at here. PD over 80, PD over 80. They equal to the same thing. So those two actually equal to. So I was this PE over EQ is also equal to PF over FR. Wait, take a look at here. Take a look at the graph. Okay. What is PE over EQ? PE over EQ is equal to PF over ER. Okay. Based on the converse proportional theorem. Okay. The two other sides are divided into the same ratio, then the line will be parallel to the base. So we actually prove that EF is parallel to QR, right? We didn't using anything to prove the triangles are similar, right? We always base, okay, because based on the basic proportionality theorem, okay, those two sides will be divided into two ratios, two equal ratios. And this two sides are divided into the same ratios too. And we actually connect with those two. Prove EF is parallel to QR. Solve the questions. Okay. Now, for this one, uh, just take a look at this one. And if you have a paper, you can just write on your papers. You don't need to like fill on the blank for this one because this one is we need to prove something. So just take a look at this graph and we will go over this question. Okay, for this one, if you just take a look at this graph, it's just so complicated, right? It has so many points, it has so many lines. Okay, why don't we start from the things we need to prove? Okay, in order to prove PQ parallel to AB, okay, we have to, if we want to use the converse of basic proportionality theorem, we have to prove, okay, CP over AP is equal to CQ over BQ. Okay, if we can actually prove those two sides are divided into the same ratio, we actually prove, okay, this line will be parallel to AB. Now, CP over AP. Look at this one, the red one. Okay, what other informations we have is we have this one. Okay, DP is parallel to BC. Okay, DP is parallel to BC. Now, if you have a line parallel to the base, the other two sides will be divided into the same ratio. So I was this, the AP over PC, or just follow the things here. Hold on. The CP over AP will be equal to the BD over AD. Okay, that's based on this one. And we also have another condition here is EQ. I would just use a different color. EQ is parallel to AC. Now, for the blue lines, okay, this one is parallel to the base. Then the other two sides will be divided into the same ratio. So this one, the CQ over BQ. This is one side, right? We have another one, it's this one. It's actually equal to AE over BE, right? The other two sides will be divided into the same ratio. Okay, CQ over BQ is equal to AE over BE. Basically like this. And for the red one, we're actually using CP over AP is equal to BD over AD. Now, if we want to have the condition here is actually okay, now this is actually this one, and this one is actually right here. So our the things we need to do right now is we actually need to prove those two things are actually the same. So we actually need to prove the BD over AD. We need to prove the BD over AD is equal to AE over BE. Okay, what is BD? Okay, BD, we can rewrite BD into BE plus DE, right? We separate the BD into two parts over AD. This one is equal to AE is actually we separate as AD plus DE over BE, right? Okay. Now, the next step is, okay, now the AD, look at here. I will just erase this part. Now, our final step is we just need to prove this is correct, right? Okay, look at what we have. The final given information here is AD is actually equal to BE. The denominator are actually the same, right? And okay, AD is equal to BE, AD equal to BE, AD equal to BE. This is D. All the things are the same. So this one actually works. So that's how we prove the two lines are also parallel. Okay. Okay. That's will be basically all the contents for today's class. And no worry about this. The proof thing will not be on the assignment, so no worry about this. As long as you understand the basic proportionality theorem will be good. Okay. And we will also have some question with similar triangles to actually make you understand how we prove two triangles are similar and how their corresponding sides are proportional. Okay. I think that will be all the contents. So if you still have questions, you're welcome to stay and ask. Otherwise, I will just call it for today. Thank you, guys. Bye bye.
Thank you. Bye.
Bye.